Hello and welcome to today's VMware webcast. Before we get started, there are a couple of housekeeping items that I would like to go over. First, we want to make this session as interactive as possible and encourage you to ask questions at any time using the question and answer box located to the left of the slides window. You can also use the question and answer box to get technical assistance if you should need it. The tabs located in the question and answer box are where you can find additional information about today's presentation. Today's presentation features streaming audio only, so there is no need to dial into a teleconference. You'll need to make sure that your computer speakers are turned up in order to hear the presenter and today's content. You can also fine-tune the audio by using the volume controls inside the media window. This presentation console allows you to interact and customize the layout to fit your viewing needs. You can collapse and expand any window on the console just like you would on your desktop by dragging the corners in or out. In addition, you can also maximize or close any of the windows on your screen by clicking the corresponding icon in the upper right-hand corner of each of the windows. At any time, you can reset the console to the default layout and access additional presentation functionality using the widgets at the bottom of your screen. Now I'd like to turn things over to today's presenter to get things started.
Hello and welcome to today's webinar on Kubernetes backup and migration strategies using Project Velero. My name is Tom Spoonemore. I am a product manager here at VMware and the project manager for Project Velero. Welcome to today's webinar.
And hi everyone, I'm Steve Kriss. I'm the technical lead for the Velero project and I work at VMware, so welcome.
So today we'll be covering Kubernetes backup, restore, and migration use cases and using Velero to perform those. There'll be a short introduction to Velero. We'll talk about strategies for protecting your cloud-native applications. And we will do a demo of Velero doing some pretty unique migration use cases for Kubernetes. So Kubernetes is very similar to other platforms in that obviously if you have an application running on top of Kubernetes, you're going to want to back up and restore those applications for various reasons. Disaster recovery is a primary reason. You want to be able to restore your application in case of some kind of an issue with it. You will want to be able to rebuild your cluster when necessary so that you can recover applications in the event of some kind of a hardware failure or some kind of a failure of the application itself. There will be data protection use cases that it will be necessary for you to address things like data loss in your cluster. And your application. If data becomes corrupt or if for one reason or another it's lost. And then for many industries, archival retention is necessary for retaining data for a certain period of time, and so that becomes a very necessary use case as well. And one thing we're seeing in the Kubernetes space in particular also is a data migration use case where you are moving your applications or your data from one platform to another. You're either rehosting from one service or one cluster to another, or you're performing Kubernetes upgrade, for instance, and you, rather than doing an in-place upgrade, you would rather upgrade to a separate cluster and then perform a backup of the first cluster and restore onto the second cluster. Also, we're seeing a number of customers that have a dev, test, or staging environment that they want to hydrate with data from one of their other environments, either their production environment or maybe they have a staging data set and they want to add that or hydrate that to a particular target environment. So these are all use cases that are necessary in any time you're hosting applications on your Kubernetes clusters. So that brings us to Project Velero, which is a open source tool that allows you to back up and recover and migrate your Kubernetes clusters and persistent volumes. It works on public clouds as really any Kubernetes cluster, whether it's a managed public cloud, an on-premise cluster that you're managing yourself, or really any other method of hosting Kubernetes cluster. Velero is built with Kubernetes in mind in that it has a specific understanding of the resources of Kubernetes and knows how to back up all of those resources, those objects, and the data that's associated with them, and store them safely so that they can be reconstituted in a new cluster. We will get into more of how Velero does that during this presentation. The basic components of Velero is there's a command line interface that's used for interacting with Velero and scheduling backups and restores. And there's also a server application that runs inside of your Kubernetes cluster that responds to the commands and also performs the backups and restores themselves. The current version of Velero is 0.11. And it's the first release under the new name Velero. If you haven't heard of Velero before, you may have heard of it as Heptio Arc. Heptio Arc is the previous name, and it's recently undergone a name change. So Velero helps your DevOps teams and platform operators configure scheduled backups, trigger ad hoc restores, backups, and performs data migrations. So the use cases for Velero are similar to the use cases we talked about before for Kubernetes. There's a disaster recovery use case and where Velero really reduces the time to recover in the event of an infrastructure loss or data corruption or other kind of service outage through its ability to restore to a new cluster or an existing cluster. The data migration use case that we talked about also enables cluster portability to easily migrate from one Kubernetes cluster to another. And it integrates with DevOps workflows to allow you to have ephemeral clones of your namespaces so that you can, if you're working in a team, for instance, of developers that are working on a similar application, they can easily snapshot and have complete copies of the development workspace common across all of the developer teams. The other thing that we're advocating for, and we're seeing a lot in the Kubernetes community, is this concept of ephemeral clusters. And that is similar to when VMs came to the fore and applications were hosted on those VMs. We had a desire to create applications that we could treat like cattle, as they say, where you can immediately, instead of actually going and fixing an application, you just kill the application and then you can respawn it fresh. So we're seeing that especially with tools like Velero, making it easy for you to restore a cluster to a given state, that customers are wanting to treat their entire cluster like cattle and literally delete those clusters rather than performing, for instance, an upgrade or other activity that would normally be a complex operation on an existing running cluster. So let's talk about traditional backups for a moment. So in traditional backups, what we have come to know in the past is that really backing up an application is effectively backing up the server. So the application effectively was the server, and so you're performing a full backup of the server, including the OS and all the supporting application dependencies, as well as the applications, and then spinning up a new server, and then laying down that backup in the form of a restore, and that's how you brought a new application or an application backup onto a new platform. But in the Kubernetes space, it's quite a bit different, right? So there's a whole cluster of machines, and that cluster of machines is running applications as pods across a series of nodes. So there's much more to consider when you're backing up a Kubernetes cluster. There are master nodes that are present. There's the etcd database that is maintaining the state of the cluster, and there are worker nodes where your actual applications are running as pods. And so how does one approach backing up the state of this cluster? That is the question that, that Velero is here to answer. So at this point, I'll turn this over to Steve, and he will take you through how Velero addresses this.
Thanks, Tom. So as Tom said, things are no longer so simple as having an application essentially be the same as the server it's running on. So in a Kubernetes environment, when we're developing a backup, recovery, and migration strategy, we really need to think about where the state is within that overall system, because the state is going to be the essential part of how we back up, recover, or migrate. And so in Kubernetes, the first place where state is stored is within that etcd database. This is the persistent storage backend for the Kubernetes API. This is where all of your Kubernetes resource definitions live. And so this will be a really important part of our backup and recovery strategy. And then additionally, if you're running stateful workloads on Kubernetes, you're almost certainly taking advantage of persistent volumes. And this will be where your application's data lives. And so again, if we're talking about backup and recovery, we need to be able to capture the information in these persistent volumes. When we think about the infrastructure that makes up a Kubernetes cluster, we have a number of servers or virtual machines in the form of master nodes and worker nodes. And really, we basically consider these to be stateless. So they're running the necessary Kubernetes components. The master's running the API server and the controller manager and multiple other components. And the workers are running the kubelet. They're running some kind of container runtime. But beyond that, they really don't themselves store a lot of the application state. And so when we look at the approach for protecting each of these sets of components, it'll vary based on whether that component is stateful or not. So first of all, when we look at that infrastructure level, at the node and cluster level, we think that rather than considering how to back up and restore these, you should really focus on being able to provision new ones quickly and easily, and Tom alluded to this before. And so if you have a cluster running and you have nodes that become unhealthy, there are tools through Kubernetes, through the kubectl command, to actually safely remove those nodes from the cluster. And then from there, you should be able to use your configuration management tool of choice, could be Terraform, Ansible, Chef, Puppet, et cetera, to be able to create a new node from a standard template that you have, and then to be able to reattach that to your cluster. And similarly to this approach for replacing nodes, we think that you should focus on automation for creating new clusters as well. One area of interesting development in this space is the work that's going on in the upstream Kubernetes community around the cluster API. And this is an effort to introduce a Kubernetes-style declarative API for provisioning new Kubernetes clusters themselves. And so the idea is that you would define an API object that has your desired specification for new clusters, and there would be a Kubernetes controller that's actually responsible for going out and provisioning all of the infrastructure and doing all of the setup work to create that cluster. So that's a really interesting way that I think folks will start to think about spinning up new clusters as needed. But so regardless of the tool that you choose for being able to provision new nodes and new clusters, you really need to focus on making those nodes and those clusters very uniform, very generic, and very reproducible. And if you do that, then point-in-time backups become less important, because if you need a new node or if you need a new cluster, you can use your automation to stamp out new copies of these resources at any time. On the stateful side, though, things are not so generic and reproducible. So the data that's in etcd or in your persistent volumes is changing as your Kubernetes platform is being used, as applications are being deployed to it, and then as your applications themselves are being used. And so this is where we really need to focus on being able to back up and restore exact copies of the data in these two components. So let's take a look in a little bit more detail at the approaches to backing up these stateful components. And so first we'll talk about possible ways to back up your Kubernetes resource definitions themselves, which are stored in etcd. So first of all, you can certainly use kind of generic block or file system level backups for the device that etcd is storing its data on. This is kind of the lowest common denominator, and it's not a bad place to start. Beyond that, etcd provides a command line tool, etcd-ctl, and this tool offers snapshot capabilities of etcd. And so etcd is a distributed system. You have multiple nodes that are making up the overall etcd cluster. And so having more application-aware snapshots will give you better application-consistent backups. And so this is definitely, using etcd-ctl snapshot capability is definitely an improvement over the generic block or file level backups. And then the Kubernetes API is actually another way that we can access the information in etcd. So we know etcd is the backing store for the Kubernetes API. So the API can create information in etcd, but it can also be used to list all of the Kubernetes resource definitions that are stored in etcd. And so this is another possible way that we can get at that information and externalize it in the form of a backup. And then on the persistent volume side, there are a couple of different approaches. So first of all, you should certainly look at your storage provider's native capabilities. Most public cloud providers have snapshot APIs for creating snapshots and then replicating that data across availability zones and regions. And many on-premises storage platforms have this capability as well. You can also use file level backup tools, and this can be really useful if you need to do, for example, single file restores. So this is another approach to consider here. And then I'd also like to mention the work that's going on in the upstream Kubernetes community through the storage special interest group, which is to introduce a snapshot API to the Kubernetes ecosystem. And so this wouldn't be a new mechanism for backing up persistent volumes exactly. It would be an API, a Kubernetes style API that wraps existing storage providers' snapshot capabilities. This is an area that's undergoing a lot of development, and so it's definitely worth keeping in mind. So let's get back to Velero now and talk a little bit about the approaches that it chooses for doing backup and restore of these persistent stateful entities, and talk a little bit about its feature set. So first of all, Velero backs up and restores both Kubernetes resources as well as persistent volumes. And so these are the two stateful components that we've been talking about. So first of all, as far as the Kubernetes resource backups, Velero uses the Kubernetes API to access the information in etcd and to perform the backups. And there are a number of reasons why we made this architectural choice, but I'm going to focus on three of them for this presentation. The first one is that using the API to access this data really enables fine-grained backup and restore of potentially individual Kubernetes resources. And so, for example, you can back up individual resource types, maybe just your deployments or just your config maps. You can back up resources only from individual namespaces, and you can even use label selectors to specify which resources you want to back up. If you're using a full etcd backup approach, you don't have this granularity to pick and choose which resources you want to back up. The second key reason that we use this approach is that in many of the managed Kubernetes offerings through public cloud providers, for example, etcd is not usually directly accessible to the user. And so any backup approach here that relies on communicating directly with etcd is essentially just a non-starter for these managed Kubernetes offerings. And then the third great advantage of using the API here is that we can actually transform the resources that are being backed up or restored to handle more complex migration scenarios. So a great example of this is that Velero enables you to restore Kubernetes resources into different namespaces than where they were backed up from. So this is a really great way to possibly create a copy of a namespace or to migrate a workload from one namespace to another. And again, this is something that wouldn't really be possible if you're doing full etcd backups and restores. And then on the persistent volume side, Velero is able to back these up, and the primary way it does this is by integrating with storage providers' snapshot APIs. So we have built-in support for the 3 major public clouds, and then this is extensible through a plugin mechanism, so we can add support for additional storage providers easily. And then there's additionally a file-level backup tool that we've integrated with Velero called Restic, and this is an open-source tool that does backups at the file level. So this is a really useful option if maybe your storage provider hasn't been integrated with Velero yet, or maybe doesn't have a snapshot API. You can use the Restic integration to get generic backups. And it's also really useful for potentially cross-platform migration scenarios where you can't rely on a single storage provider's snapshot format because you need something that's portable across providers. So let's take a look at a simple Velero workflow and what that might look like. So in the diagram here on the left, we have our first Kubernetes cluster. And in this cluster, we're using Velero to take a backup of a particular namespace. And so Velero is installed in this cluster. It's communicating with the Kubernetes API to fetch all of the resources that are deployed in that namespace. And it's also going to identify any persistent volumes that are used by that namespace, and will take snapshots of those using the storage provider's APIs. And all of this data will be uploaded to the cloud somewhere. So the Kubernetes resources are uploaded to object storage, and snapshots will be stored in the storage platform. And then on the right, we have a second cluster, cluster B, which is actually executing a restore. So the cluster B is connected to the location in the cloud where cluster A's backup was created. And so cluster B is able to execute a restore of that backup and reconstitute the Kubernetes resources in cluster B and get restorations of the persistent volumes from those snapshots. And so this is a great demonstration of potentially a disaster recovery scenario where maybe we lost cluster A and we needed to restore service into a new cluster. It's also a great example of a migration scenario where we simply have a workload or a namespace that we want to move from cluster A to cluster B. And so what I'd like to do now is actually jump into a demonstration of some of the capabilities that Velero has in action.
So I'd like to show 2 examples of using Velero to back up and restore applications running in a Kubernetes cluster. So for the first example, I have a Kubernetes cluster running in AWS, and I have a WordPress instance running within that cluster. So if I take a look at the deployments that are running in my default namespace, I'll see that there's a WordPress and a WordPress MySQL deployment running. And additionally, we have a couple of services running, and each of those deployments has a persistent volume claim that it's using as its backend storage. Now, on the bottom here, I have kube-controlled port forwarding set up so that I can access the WordPress front end through my local browser. And so if I switch over to my browser, refresh the page, we'll see that Steve's awesome blog is running. And so far, I don't have any posts. So the first thing I'll do is actually create a new post. Title it Hello World. And I think I'll say hello from cluster 1. So I'll go ahead and publish that. And if I go back to the front page, we'll see that I have a post. So now I'll go back to my terminal, and the next thing I'd like to do is create a backup of that WordPress application. So I'll say Velero backup create, and I'll call it WP for WordPress. And then I'd like to include everything in the default namespace. So I'll specify include namespace as default. And then I'll also specify the wait flag, which will just wait for the backup to complete. So I'll go ahead and run that. And Velero is now communicating with the Kubernetes API and getting all the resources running in that default namespace. And it's also looking for any persistent volumes that are being used by the resources running in that namespace. And if it finds them, it should take snapshots of the underlying cloud volumes. So since we're running on AWS, those persistent volumes are backed by EBS volumes. And so we should get EBS snapshots of those volumes. So the backup's completed now, so I'll go ahead and run a Velero backup describe command for the WP backup. And I'll pass the -- details flag, which will give me some more detailed information about the backup. Now there's a bunch of output here, but I want to just look at what's on the bottom, and we see that under the persistent volumes section, we have 2 snapshots that appear. And we have some information about the snapshot IDs and other information about the volumes that are being backed up. So far this looks pretty good. So what I'll do now is I'll actually simulate a disaster by going ahead and deleting the WordPress application from this cluster. So I'm going to say kubectl delete deployment services and persistent volumes that are labeled with app equals WordPress. I'll go ahead and run that. And I'm also going to stop my port forwarding command down here on the bottom. And so all of these resources are being deleted now, and that's complete. And so if I switch back to the browser and refresh, we'll see we no longer have a connection. So the next thing I'd like to do is switch to my second terminal window here. So I'm going to click on that. And this terminal is connected to an entirely separate Kubernetes cluster. It's another cluster running in AWS, so we'll call this one cluster 2. And what I'd like to show you is the backup locations that are configured for Velero running in this cluster. So if I run Velero backup location get, we'll see that there are 2 backup locations configured for this cluster. And the first one is actually named cluster 1. And the bucket that it's pointed to is called Velero Backups. Now this is the bucket that actually cluster 1 was pointed to, and so the backup that we took a minute ago is actually stored in this bucket. And then additionally I have a second backup location that's called default, and so any new backups that I take from within cluster 2 will be stored in this backup location. But the important thing is that since we have a backup location configured pointing to cluster 1's bucket, we should be able to access the backup that was just taken from cluster 1 within this new cluster 2. And so if I run a Velero backup get command, we'll see that the WP backup, which I just took, is available in this cluster for restore. Now I'll show you that I don't have any deployments, services, or PVCs running in the default namespace apart from the Kubernetes service, which is not part of the WordPress application. So what I'd like to do now is go ahead and restore this backup into cluster 2. And ideally, my blog will come back up and we'll have that post that I just created a minute ago. So I'll say Velero restore create. I'll say from backup and give it the backup name, which is WP. And then I'll just specify the wait flag so that we can wait for the restore to complete. I'll go ahead and run that. And so now Velero is pulling down the backup from the Velero Backups bucket and finding all of the resources that are stored within it and restoring them into the cluster 2. And additionally, it's finding those EBS snapshots that were associated with this Velero backup, and it's restoring those to new volumes and then associating the persistent volumes that it's creating here in cluster 2 with those new EBS volumes. So this restore should take just a couple more seconds to complete. Great, so our restore is now complete. And so now I'll go ahead and look, and if I run kubectl get deploy, we'll see that both of my deployments are there. And if I look at PVCs, we'll see that I have both of my PVCs that were just created. And finally, I'll look and see if my pods are up and running yet. And great, so we have a WordPress pod that's now running and that MySQL pod that's running as well. So I'll set up the port forwarding command again so that I can hopefully access the WordPress UI through my browser. All right, and so now I'll switch back to the browser, and if I refresh this page, we get reconnected to Steve's awesome blog, so that's great. And if I scroll down, we have our Hello World post, so hello from cluster 1. So this WordPress site is now entirely running in cluster 2. We backed it up in cluster 1 and restored it into cluster 2. So that hopefully gives you an idea of how you could either do a disaster recovery into a new cluster running within AWS, or if you simply wanted to migrate a workload, of how you could migrate from one cluster to another. So let's move on to the second example, where I'd actually like to migrate this application out of AWS and into a cluster running on GKE, on Google's Kubernetes engine. Now, we can't use EBS snapshots to do this migration because Google's cloud doesn't understand anything about EBS snapshots. And so Velero has a generic mechanism for backing up volume contents called Restic. Restic is an open source tool for doing file level backups. And so what I'd actually like to do now is take a backup from cluster 2 using Restic to back up the contents of those volumes. So I'm going to clear my screen here. So the first thing I need to do is to tell Velero to use Restic to back up the volumes. And the way that this is done is by annotating the pods that have those volumes that you want to back up. And I have these commands saved in my buffer because they are a little bit long. So first I'll annotate the WordPress MySQL pod, and then I'll annotate the WordPress pod. And this is telling Velero that next time it runs, it should use Restic to back up these volumes rather than taking EBS snapshots. So what I'll do now is I'll say Velero Backup create. I'll call this backup WP-Restic. And I'd like to, again, include the default namespace. And I'll use that -- wait flag. So Velero, again, is getting all of those API resources that exist, but rather than taking EBS snapshots of the persistent volumes it finds, it'll be using Restic to back up the contents of those volumes. So we'll give this a few more seconds and it should complete. Great. So now if I run the Velero Backup describe command for WP Restic and I pass details, what we see at the bottom is rather than having information about EBS snapshots, we have a section about Restic backups. And we see those 2 volumes that we asked to be backed up are included there. So that's great. I'm going to stop my port forwarding command here. And I'm going to go ahead and delete, again, the deployment, the service, and the persistent volume claims from this cluster. And I'll switch back to the browser and show that we no longer have a connection there. All right, so that deletion is complete. So now I'll switch over to my third terminal window here. And you can see that this is a cluster that's running in GKE, so an entirely different provider. Now, if I look at the backup locations that are configured here, again, we see 2 backup locations. And the first one is called AWS, and it's pointed to that Velero Backups 2 bucket, which is where all backups that were created in cluster 2 were going. And so because that's configured, I should be able to see the backup that I just created if I run Velero Backup get. So we see WP Restic. So what I'd like to do now is just do a restore from that backup. So again, we'll say Velero restore create from backup WP Restic, and we'll wait for this to complete as well. And so now the Velero instance that's running in cluster 3 here, running in GKE, is going out to the S3 bucket, pulling that backup down, and it's additionally pulling down the Restic backups of the volumes that we backed up from cluster 2. And because the Restic backup is in a generic cloud provider agnostic format, that data can be restored into new persistent volumes in GKE. So this should take a few more seconds to complete. Great. So the restore is completed now. And so I'll just take a quick look and see if our deployments have appeared. We have both of our deployments. And if we look for persistent volume claims, we'll see those as well. And finally, I'll look and see if our pods are up and running. So we have 2 running pods now in our GKE cluster. So I'll set up the port forwarding command one more time from this cluster. Great. And so now if I switch back to my browser and refresh this page, Steve's awesome blog comes back up. So this is now being served from GKE. And if I scroll down, we'll see my blog post, Hello World, that was written hello from cluster 1, that's up and running now in GKE. So I showed you how we could migrate applications from one AWS cluster to another using Velero's built-in support for cloud provider snapshots, in this case EBS.
Okay, that was very good demo. So I just wanted to remind everyone that Velero is a open source project. We currently have about 75 contributors and 2,300 stars on GitHub. We would love to have you all download and try Velero, and also, if you want, become a contributor for Project Velero. Follow us on Twitter at Project Velero. We also are present on Kubernetes Slack channel at the Velero channel, and you can get involved with our mailing list on Google as well at Project Velero. We just had a community meeting this week, but we have community meetings the very first and third Tuesday of every month, and you can find out more about that on our GitHub site as well at Heptio Velero Community. And be on the lookout for a new Velero website, which we should be launching at the beginning of next month. So, so at this point, we will take some Q&A. I know that we've been answering some questions online, but I think there's some additional ones that we could take here. Is Velero capable of restoring labels, annotations, and taints on Kubernetes nodes themselves?
Yeah, so I can jump in for that one. So today, Velero considers the node API objects non-restorable resources, where we essentially consider these part of the cluster infrastructure, and so we don't actually do any restoration of them. So you wouldn't be able to copy these over from a backup onto the nodes. We are considering adding some additional functionality to Velero, though, to allow you to sort of merge the contents of a backup into a running cluster, so that if you already have node API objects in your cluster, you could do things like take the labels from the backup or take the annotations from the backup on that node object and apply them to the nodes that are currently in the cluster. So it's definitely something that we're thinking about, but today nodes are kind of a special API object, and we basically do not restore them.
Okay, great, Steve. Here's another question about Restic. Does Restic take a file system snapshot before making a backup?
Yeah, so as I mentioned, Restic is a file level backup tool, and so it is taking a backup at the file level. It supports incremental backups, and so typically the first time you use Restic to back up your persistent volume, it will take a little bit longer to capture all of those contents, but then on an ongoing basis, you'll get incremental backups. So just the blocks of data that have changed or the files that have changed will be uploaded. And so related to that, Velero supports the concept of pre and post backup hooks that can be executed within your pods. And so you can run whatever command you need to within your pod to sort of help you ensure that you get consistent snapshots. So you can run fsfreeze commands before backing up a pod, including the volume, and then run an basically an unfreeze after the backup. Or if you have application-specific commands that you need to run to quiesce your application, you can do that before and after. And that applies for both snapshots through your storage provider as well as for Restic.
Another clarifying question on Restic in terms of the incremental nature of it. So is it full plus incremental, and is it, you know, after the full, is it forever incremental, or is there a period where it stops being incremental and it goes back and takes another full and then starts doing incremental after that?
Yeah, so Restic's approach is to the first time it's backing up a particular directory or a particular volume, it will take a full backup. And from then on, if the Restic repository that you're backing data up into, if it has a previous backup of that directory, it will use that as the basis for a new incremental backup. So essentially, once you have your first full backup, each additional one will be incremental. But if at any point you delete your old backups from your Restic repository, which is something you can do through the Velero command line interface, the next backup that's taken will be a full backup.
Okay, fantastic. Are there other questions on the call? I know that we answered a bunch of them, and I believe that you should be able to see those answers in the Q&A panel on your in the browser. Well, good. If there are no further questions, then I would like to extend our thanks for attending the webinar today. And we are hopeful that you will take a look at Velero and give it a try. Thank you very much.
Thanks a lot, everyone.